In the next example, we're asked to calculate the molar mass of a gas. A sample of a gas has a mass of 0.311 grams, its volume is 0.225 liters, and temperature is 55 degrees C. The pressure is 886 millimeters of mercury. Find its molar mass. Remember, the units of molar mass are grams per mole. Okay, so we need to find the mass and the moles to work this problem. The mass was given, and we can use the gas law formula to find the moles. Okay, so first we need to make sure that everything is in the proper units to work the problem. Okay, so what we're going to do is convert all of the units. The pressure from 886 to atmospheres is 1.1658 atmospheres. The temperature is 55 plus 273. That gives us 328 Kelvin. The moles we calculate from the ideal gas equation. Remember, PV equals nRT. Solving for N, we get PV over RT. When we plug that in, we get 1.1658 atmospheres times 0.225 liters divided by the gas law constant, 0.08206 liters atmospheres per mole Kelvin, and 328 Kelvin for the temperature. Now, when we calculate, we get 9.7454 times 10 to the minus third moles. Now we have the mass and the moles, so we can calculate the molar mass, which is 0.311 grams, divided by 9.7454 times 10 to the minus third moles. That gives us 31.9 grams per mole. Now we'll work the for practice problem. For practice 6.8 says, the mass of a sample of gas is 827 milligrams. Its volume is 0.270 liters and temperature is 88 degrees C. The pressure is 975 millimeters of mercury. Find its molar mass. Well, the mass is 827 milligrams, so we've been given that. Now we need to calculate the moles from the ideal gas equation and divide mass by moles. Okay, so first we'll go ahead and convert the mass to something to the correct units for this problem. So 827 milligrams, we divide by 1,000 to get 0.827 grams. Now we have our mass in the correct units. Next we'll convert the pressure. The pressure in atmospheres is equal to 975 millimeters of mercury. Remember that 1 atmosphere is 760 millimeters of mercury, and that gives us 1.2829 atmospheres. Okay? The temperature in Kelvin is equal to 88 plus 273, which is equal to 361 Kelvin. Now we can solve for the moles. As we determined earlier, N is equal to PV over RT, and that's equal to 1.2829 atmospheres times 0.270 liters. Oh, I see that. You can't see the right side of my screen. Let me go ahead and move this down. Okay, so here we have N is equal to PV over RT. So that's equal to 1.2829 atmospheres times 0.270 liters divided by 0.08206 liters atmospheres per mole Kelvin, that's our gas law constant, times 361 Kelvin. Okay, so that's equal to 1.1693 times 10 to the minus 2 moles. Okay, now to solve this problem, we simply need to divide the mass by the moles, so the molar mass is equal to 0.827 grams divided by 1.1693 times 10 to the minus 2 moles, which is equal to 70.7 grams per mole.